Hello, and thank you for joining today's webinar, Electrification Solutions for Electric Recreational and Marine Transportation. My name is Adam, and I am joined today by our presenters, Paige Szyszewski and Steve Webb from Parker's Assembly and Protection Solutions Division. Just a few housekeeping items before we get started. Please make sure your microphone is set to mute during the entire presentation. There will be a brief Q&A session following the presentation. If you have any questions during the presentation, please submit those to the Q&A box and the team will answer those at the end. There will be a brief survey to fill out at the conclusion of today's webinar. Please fill out the survey so that we can enhance our future webinar offerings. Finally, an on-demand presentation will be available and sent to your email following the webinar. With that being said, I'll turn it over to our presenters.
Thank you for the introduction. Hi, everyone. Welcome to the webinar, and thank you for coming on. My name is Paige Szyszewski. I'm a territory manager based out of Minnesota in the upper Midwest, so I'm supporting electrification customers. And we also have the great Steve Webb on the call with us, application engineer. And today we'll be discussing solutions specifically for electric, marine, and rec vehicles. So today we'll go through a quick background on Parker and who Parker Lloyd is, some trends in the market, products and applications, and then lastly, we'll wrap it up and open up for some Q&A. And as mentioned before, if you have any questions, feel free to submit those at the bottom and we'll go ahead and answer those at the end. So Parker as a whole is a very large company, as you can see, but we are a global business with a local focus. Who is Parker Lloyd? We'll dive into a little bit on who we are. We benefit from servicing a lot of diverse customers in the electrification market, one of those being automotive OEMs, which we've seen trends start in the automotive and kind of transfer into other industries. We've been lucky enough to be involved in the earliest parts of the automotive electrification space. So that's where a lot of products were quickly created to support the move of electrification. So we do carry a lot of those products that are going to be directly applicable to the applications that we're seeing in rec and marine vehicles as those turn more and more electrified. We're here to be your partner of choice, and we've got the global manufacturing. We have a team of dedicated application engineers that can assist with product recommendations, testing, and really be there to help find solutions so that we can all grow together. We've got the ability to customize and scale up with new products, and we really demonstrated that from the very start with the move towards electrification. So through all of these efforts, we're here to help our customers find solutions, meet their goals, and grow. As you can see, where we're at in the US, we've got manufacturing in Indianapolis, Indiana, and Sagertown, Pennsylvania, and then we've got R&D based out of Cary, North Carolina, and then a satellite testing facility in Detroit, Michigan, as well as an analytical lab in Erie, Pennsylvania. So then we do have those manufacturing and tech centers all across the globe to support those regions that we do business in. A little bit more about us. We care about working for a better tomorrow. So we value quality, safety, and sustainability, as you can see through our goals here. At Parker, we're a huge company, so we've developed a new brand, EV Onward, and that helps to collect and summarize the products that are directly applicable to electrification. So we've got the sealing and gasketing, EMI shielding, but today we'll focus on the products that Steve and I are responsible for, and that's the thermal management, structural adhesives, and coatings. So with that, I'll pass it off to Steve, who's going to dive into some trends, and we'll get into some applications after that.
All right. Thank you very much, Paige. My name is Steve Webb. I'm one of the senior application engineers here at Parker Lloyd, and I'll take it forward from here talking about some of the applications and things going on. First, I'd like to talk about what's kind of driving that marine and recreational electrification. So there's some trends going on. So I'd like to talk a little bit about some of the government regulations. One of the trends that is really kind of influencing things on rec, marine, and electrification. So governments across the globe have gone up there and put regulations in place, as everyone knows, to really curb emissions. And that's one of the things of decarbonization. Furthermore, there's other regulations going on the performance of the batteries. So those are some of the things that are also driving the trends on electrification. As well, there's a desire from a customer standpoint to be more eco-friendly with this recreational equipment out there in the environment. Another trend that's moving on is really kind of the automotive sector. So the automotive sector has pioneered and driven forward electrification with battery electric vehicles and hybrid electric vehicles. And with that groundwork being laid, there's now a faster development cycle than we're seeing in the passenger car and the truck market. And then lastly, some of the technological and performance advantages. So out there in the marketplace, you really can get a better performance out of those vehicles using some of the battery electric, high acceleration, et cetera, and different performance. So some of the needs in the growing market. When we're coming into this market space, we're really coming in from our experience as a market leading company on the electrification of vehicles. And we understand a little bit on what's really kind of needed there really to advance these markets on battery electric, recreational vehicles, outdoor vehicles, et cetera. One of the first ones is really off the shelf reliable materials. You need something that's proven technology, that's already been fielded. That certainly gives quite a bit of confidence in moving forward in manufacturing. In the same tone, that pedigree with automotive, that consistency and quality that we've developed and already supplied to the marketplace. You want the ability to quickly ramp up production, and that kind of goes hand in glove with the materials on hand and already commercialized and a known commodity out there. Supporting that brand production, with on-site application engineering, so helping you develop through those new applications, new battery designs, implementation of those new processes and materials, et cetera, really working hand in hand with the engineering group. A team really kind of that understands the value of the energy output rates are kind of evolving. The batteries themselves and their designs are evolving. So someone who can quickly respond. And we've been doing that with the automotive group for quite a while, and as well with this marketplace, the recreational marines. And then lastly, solutions that really kind of do tailor themselves to some of the unique needs of the recreational marine market. So those materials that will withstand a marine environment, those materials that provide high battery energy density and support the temperature and so forth that are associated with those types of applications and those types of designs. So kind of really, we've talked about it a little bit before, but what does this really mean for material selection? Well, out there in the marketplace, when you're designing for these types of vehicles and so forth, you really do need thermal management materials that really work in tandem with some of the crucial components, both to insulate and also the batteries themselves from extreme temperatures to bleed heat out of those batteries and get peak performance out of them, but also some that isolate shock and vibration and seal up the entire battery enclosure, as well as some of the ancillary components. Certainly this, by the converse, it means you don't want to use materials that are not proven, so those brand new materials. Certainly we do work hand in glove with customers to develop new products, but that does lengthen the development cycle and the implementation cycle. So we're really bringing to the table here products that are already proven and are already out there in the marketplace. So the next couple of slides, we're going to talk about various applications that we've really already fielded out in the marketplace. And some of the cases, the form factor will change, but the individual components are largely the same. Design changes a little bit and where they're located, but these applications are largely consistent across these different platforms. So in the first one here, electric snowmobiles, whether it's the infotainment, the navigation system, board, and ship level electronics, we've got materials and do potting and encapsulation and thermal management, et cetera, as well as the battery pack itself, critical to the overall EV application. Those potting and applications, thermal conductive gap fillers and so forth, or thermal interface materials, adhesives, structural adhesives, dielectric coatings, et cetera. With respect to the motors, we do supply potting, encapsulation, and thermal management material, and I've got a slide a little bit later on to talk about that and some of the advantages with it. And then last one would be the ancillary equipment, which would be kind of your charger inverter for the individual platform, but also the charging handle and charging stations. All of those are going to kind of require some of the same things. Again, potting and encapsulation, thermal management, potentially dielectric coatings. Now looking at an ATV, and again, we've supplied applications and components to this market space and for these types of applications. And again, they're largely the same on each platform. They may change for the individual customer needs or what the individual platform needs are, such as a marine versus a snowmobile. But again, they kind of go right across the board with the same types of applications. So that infotainment, the battery pack itself, the motor, and the charger inverter, all those on the platform itself, as well as the ancillary equipment of the charging station and the charging handle. Looking at personal watercraft or PWCs, those marine type applications, again, same thing, charger inverter, the motor itself, the charging handle, those types of applications, as well as critically the battery pack and the infotainment, and as well as the charging station as an ancillary. All those materials have to be able to withstand the marine environment. And in some cases, there's some unique regulations regarding marine. Again, scaling up to more of a larger class of marine vehicles, very much the same thing. Motor, the battery pack, that charger inverter, and then the infotainment navigation, all those requiring the potting and encapsulation, thermal management materials or conductive gap fillers, gels, greases, etc., and thermally conductive materials in general to make those performant, give them their peak performance, and really take these type applications and platforms a step ahead into the new generation. And then lastly, those ancillary of charging handles and charging stations. One note on that, we've talked more about the personal vehicles in the marine market. There is another market on the commercial side. However, that is still being sorted out with respect to international organizations when it comes to flame and battery power density, etc. So right now, those are kind of in a state of flux with respect to the regulations and performance. However, ship-side power applications, much like you would see with trucks at a truck stop, where they're using on-site power as opposed to on-board power, which reduces the carbon footprint. We can also work with those type applications in the commercial marine segment. So moving forward, we've talked a little bit about the generalized applications. What I'd like to now is get into more of the nuts and bolts of the adhesive and thermal management materials, which we offer into the marketplace. So thermal management materials essentially kind of fall into two categories here. So you've got gap fillers, which really provide thermal management between a battery and a cooling plate or the battery pack and the outside of the vehicle. So get energy and thermal energy outside the battery itself. And then potting and encapsulants or even low density, depending on the weight needs of the platform. Those will provide thermal management and shock protection inside the battery itself through the various cells and all the way out to the outside. And then lastly, we've got some materials, structural adhesives, and sealants to help bring the whole package together and seal up the battery itself. So moving into the applications, here we've got a marine battery pack. And so we've got different types of materials. Gap fillers, again, as I mentioned, those things are liquid dispensed critically materials so that can form and fill the entire gap and all the airspace in between the battery itself and a cooling plate. We've got the potting and encapsulants, which would go inside. Here we see a cylindrical design, filling up that, giving thermal conductivity between the battery's individual cells or the cell packs, etc., all the way to the outside. We've got thermal adhesives, so we can actually bond the batteries themselves in a structural application down to the cooling plate itself. And then low density, again, low density is an option when customers are really looking to lightweight them and maybe look for extended range or extended performance out of the platform. So we've got easy to dispense, we've got customizable materials. When we work with you on those types of applications, we can show you some of the different materials within a given family of adhesives and how well we can alter them or change them, even with an existing off-the-shelf material to give different performance requirements. So this is a slide I mentioned before regarding motor potting. Some of the cool therm materials, these are designed really to go into the end windings and stators. And they're designed to pull energy out of the motor itself. And it really kind of gives a couple of different options to the design crew and the design engineers. What you have is the ability to pull energy out. So you can get an increase in performance and a decrease in temperature. So as the temperature decreases, the overall performance of the motor itself will increase. And then the other side of that coin is if you're looking for a different form factor, you can downsize the motor itself and get equivalent power output by having a cooler running motor. So it kind of gives a design option. You can either go smaller, and have equivalent power coming out of the motor, or you can have the same form factor and size and get greater performance out of it just by really lowering the temperature and going with these pottings and encapsulants. And again, they're all designed to flow into very tight crack cavities and crevices, the end windings and the stator slots, etc., and certainly perform within the temperature range of all these electric motors, clear up to 200 degrees Celsius. So throughout the platform slides, when we talked about the different applications, one of them is that ancillary equipment of charging systems, right? And so those applications, we've got gap fillers and thermal materials, as well as pottings and encapsulants that can go in here. So the potting and encapsulants on these slides are kind of shown in green. So those materials would provide vibration and performance and protection, as well as sealing from the outside elements, as well as protecting the end consumer with an overall design. And then you've got a gap fillers and so forth within the handle itself. All those are necessary within the handle itself, so it's a better option for the consumer, and it's a safety aspect to reduce the heat as they're utilizing this equipment. So these things, we can tailor them or give you the custom solutions for high thermally conductive materials and that low viscosity to go into it, or hit the right viscosity, as we found with a number of customers, where it flows in exactly and doesn't flow where it doesn't need to. So that's sometimes a critical aspect in these designs. On this slide, talking about some of the key applications in thermal interface or thermal management materials for electric marine. We've got a number of silicones and urethanes, as well as one of the epoxies here. So on the gap filler side, these are liquid applied materials that tend to go in, as I mentioned before, between the battery and the cooling plate. We've got some materials, and they range from 2 up to about almost 4 watts per mole Kelvin of thermal conductivity, either silicones or urethanes, depending on adhesion and or moisture exclusion needs that come with the urethanes. And on the potting and encapsulants, again, lower viscosity materials that flow into all the small cavities and so forth within the power electronics. We've got a couple of them here. Again, silicone epoxies and urethanes. And again, they're ranging from that 1 to about 4 watts per mole Kelvin. So in this slide, I'd like to talk a little bit about battery safety. Certainly it's important on every platform, but sometimes within a marine environment, there are additional regulations that are regarding this. We're probably going to see them coming out from government regulations in a safety standpoint, whichever organizations may cover some of the off-road vehicles or light ATVs, etc. But certainly within a marine, it's really critical from a fire and safety standpoint. So we've got a couple of different products. One of them is the top cell foam. So this is designed and optimized with a viscosity to flow out in between the cells, cover it completely, and it's a UL94 V0 rated material. Basically, it helps reduce the propagation of thermal runaway, and those allows at the same time individual cells, cell packs, etc., depending on the design, to vent the heat and fire directly away from the battery itself without catching additional cells and or cylindrical materials to the next to them, allowing them to vent, flame out without having the cells adjacent to them catching fire. Another one I'd like to talk about is the intracell foam. So this is a low viscosity. It's designed to really go down into those small gaps. A foam product that is UL94 HB to V0 rating, very soft product. And again, isolate individual cells, individual packs, and whatever the design may be to prevent that thermal runaway. Again, it's kind of critical to have these types of applications as we've moved in our development cycle with automotive and EV automotive. We have learned that these have become critical, and we're expecting that same criticality to carry over to some of these type platforms and within the marine environment, certainly, but also potentially within some of the off-highway and recreational equipment. Okay, so going forward, I'd like to talk a little bit about some of the structural adhesives that we offer into this marketplace. We've talked about how to enhance the performance of the motors and the batteries and the power electronics, now how to seal it all up and how to put the actual applications together. So here at Parker Lord, we're offering structural adhesives. They can either be a traditional structural adhesive, or we can even offer thermally conductive structural adhesives, kind of unique to the marketplace, where we can actually take things like the picture on the right shows here, where we're taking a thermally conductive structural adhesive and bonding the individual battery components directly to the cooling plate, but at the same time providing a structural bond and as well thermal pathway to take heat out of the application. We have materials for hem flange bonding or general assembly, certainly composites, plastics, and metals. One of the first applications, really talking about here a type of product, Cooltherm TC2002. This is a cell to plate type application. You can see here on the right what's going on. We're taking individual cells and bonding them down to the cooling plate itself. We needed strong structural performance as well as thermal conductivity in this application. Again, some of the unique features that we offer into the marketplace within our portfolio, materials that are both structural as well as thermally conductive. And if you don't know already, most adhesives actually act as an insulator as opposed to a thermally conductive pathway. So we think we're offering some unique components and materials into that market space really to help differentiate ourselves. And normal products, so you'd expect it UL 94 V0 flammability rating, etc. And we can talk about different applications if you have greater needs for greater thermal conductivity and looking at custom applications and custom designs. So the next two slides just talking about the individual components and how they're put together within the cells and within the battery itself. In this case, it's a cell to carrier application. Looking at a 5206 adhesive, this material, very fast, low viscosity structural adhesive. Really what it's designed to do is take those cylindrical cells and bond them to the carrier plates themselves. It has a very fast cure, so it allows the manufacturers to invert those carriers and then bond or pot the other side, bringing both ends of the cylindrical battery, conforming them and bonding them directly into that carrier itself. So moving on with that same design, so again, a cylindrical cell using carrier plates and so forth. What we're looking at here is using 5206, like we mentioned in the last slide, or one of the MaxLock products. Once the batteries themselves have been attached with all the different wire strands within the individual components and battery, then the current collector bonding, this allows them to stabilize the entire design. So we're using two potentially different structural adhesives to bond those applications. Again, they're a liquid dispensed, two-component material, very precise application, so they can put down as dots and so forth and perform quite well in this type of application, giving a structural strength to that individual subcomponent of the battery. So now we've got looking at this slide, we've got the battery itself begun to be assembled. We've got the individual subcomponents. Now we're looking at the enclosure itself. This would be when we're sealing up the enclosure. This would be after we've looked at the different potting or encapsulants that may have gone into that battery itself, and to provide the thermal management within the battery itself. And then also at this point in time, the top cell foams or intercell foams would have also been applied. So this is kind of that last step where we're sealing up the module. In this case, looking at either a non-structural or a structural application. And this first one we'll talk about is a structural, using a 7555 urethane. That particular material is moisture resistant, bonds well to composites and plastics or coated metals, really designed as a liquid dispense, fill in individual channels, etc. Now, if the customer is looking for something that is potentially repairable, where they can open up the top of the cell, we're looking at a sealing type material, 7610 DTM. So that's a one component material, which can be used to form kind of a form in place gasket. It doesn't expand, but it is moisture resistant, bonds directly to metal, and then the individual attachment brackets and so forth can be attached or however they're sealing the individual battery itself. In this slide, talking more about permanent sealing of the battery. Again, after the modules have been assembled and all the different thermal management materials have been put into it, these types of designs of batteries are one where it doesn't afford the consumer the ability to get into them. So from a safety standpoint, but at the same time also really kind of offering a permanent structural bond to it. In that case, we've got a couple of different products here. Looking at 7000 series urethanes, we've got a number of different urethane families, depending on the different materials, coated metals, or composites. And then as well, looking at a couple of different materials, MaxLock and 850 series, which are designed to bond and seal bare metals, composites, and plastics. All these materials have been tested against within the automotive industry, looking at coolant applications and compatibility, where it's a cooling plate or you have an actual coolant stream flowing over that, so we don't disturb that or degrade the performance of it. Again, these are two-part adhesives, really designed as a permanent fixture And they are also designed so that they have a minimum or no individual fasteners or clips that are holding the battery tops together. Talking about just a couple of quick complementary products. So these are structural adhesives that may be used to bond down dissimilar materials, really looking at a wide range kind of an applications within here. A couple of different products that might be used. Maxlock family of adhesives, the Lord 7545. This is part of the 7500 series of urethanes, and then the 850 series acrylics. Really, these are designed to put down small bits of bracketry, cross members, flanges, etc., or even fixturing of the individual components. There's always a need for those kinds of things. And so we do offer a couple of different adhesives, some of the same ones that we can use to seal up the batteries themselves or provide structural components within the design and assembly of the vehicles, thus minimizing kind of the supply chain and the different components that might be coming into the individual factory. So just to kind of summarize it here, some of those key adhesives for the electric rec and marine market space, the 850 series acrylic, there's a couple of different products in that family, high lap share strength. The 5206 quite often used as a potting or staking material, really fast reacting, allows for assembly of the battery components. The 7545 series of urethanes, it's a family of products sealing up batteries, looking at individual subcomponents within the battery, a number of different applications there. And then as I talked about kind of in that first slide, the TC2002, this is an acrylic structural adhesive that also has the thermal conductivity component to it. Now I'd like to change gears a little bit and talk about a few of the coatings that are necessary for these types of applications. So within the battery space or electric space, coatings are necessary really to provide dielectric coatings on your individual components. They offer electrical insulation, if you would, for a wide range of designs, quite often here used on cooling plates. We offer it into the market space an epoxy coating, a dielectric, as well as a UV cure sample. And we'll talk about those on the subsequent slides. The first coating I'd like to talk about is the UV cured Cipial UV. So this coating is a VOC dielectric coating. So again, it's designed to provide electrical insulation on individual components, as well as does provide improvement in adhesion. So you can see here we've looked at a number of applications on cooling plates, individual cell packs, etc. And it can replace the PET on cylindrical and prismatic cells, really improving that bonding performances and eliminating delamination common with PET. The UV cured material does offer a really good performance as well on very sharp edges and designs. It really is a unique coating in the marketplace with some of those advantages. And now I'd like to talk about one of the other more standard classic coatings. So the Lord JMC 700K, this is a heat-cured thermally conductive material, does provide dielectric coating. The JMC 700 has been in the marketplace for quite a while. It's designed to provide insulation on the individual cooling plates and components and dividers within the battery themselves. And it really does designed to improve the performance as well as kind of replace existing coatings that may crack, so some of the powder coated applications, etc. And I'd like to thank everyone for coming. At this time, we'll go ahead and open it up for questions and then touch base on some of the ones that have been offered up in the chat. Sound good, everyone?